I'm sure the 8 o'clock class appreciates knowing that they're the warm-up.
Oh yeah, I just come out and tell them, it's like, well, hey, everything's gonna be a mess. I can't form sentences at 8 o'clock. And they're like, oh, but you have to teach us. I'm like, oh, well, you have to learn. And they're like, oh, don't you have any responsibility? And I'm like, oh, moving on. And so anyway.
That's us next semester.
Yep. Next semester, y'all are gonna be at 8 o'clock, and I'm gonna be like, oh, all right, y'all figure this out. I'm gonna go have some more coffee. And then I just write problems down and I just walk away. I'm just kidding. I just act like I walk away when really I'm just kind of like taking a quick nap. So let's take a look at problem 2. Remember that when we're looking at antiderivatives, when we learned our rules, add one to the exponent, divide by the new exponent. Doing antiderivative stuff defines a family of functions, but then they have that plus c at the end of it. If we have an additional piece of information about the antiderivative that we're looking for, then we can figure out what that plus c is. And so what we've got is we've got the integral from 2 to 6 of little f dx equals 9, and we're told that capital F of 6 is equal to 12. So really, if we go to our fundamental theorem, we're given two of these 3 pieces of information. So we know that the integral from 2 to 6 of little f of x dx is equal to capital F at 6 minus capital F at 2. And so now I have how much the function changed, the function capital F changed from 2 to 6, and I know where the function ended up at 6. So I can plug in the 12 for f of 6, the 9 for the integral from 2 to 6, and that'll allow us to solve for f of 2. So this tells us that f of 2 must be equal to 3. Capital F of 2 must be equal to 3. We were told where we ended up. We were told how much things have changed, so we can go backwards and figure out where we started. Any questions? There's a second part to this problem, which uses a completely different function with some different values. Or it could be the same function. We're told that the integral from 0 to 500 of little f, if I could draw them backwards, maybe that would help, is equal, the integral from 0 to 500 of little f of x, the x is 0. And it says, what is the relationship between f of 500 and f of 0? So we're asked, what's going on here? What's the relationship between f at 500 and f at 0? So what we know is from our first fundamental theorem of calculus that the integral from 0 to 500 of little f, I don't know if that's going to work for me for writing f's that way, at least they look different, is going to be capital F at 500 minus capital F at 0. And we're told that this difference is equal to 0 by hypothesis. So that's just, we're given that. And so that tells us that f of 500 and f of 0 must be equal. The definite integral tells us how much the function changed. The definite integral of a derivative tells us how much the function has changed. If the definite integral is 0, that means the function hasn't changed. That means f of 500 is the same as f of 0. Any questions? Rad. Let's pause the video here and do some more problems, because that's most fun. So the next problem is very visual. I'll try to send out a picture. That'll do. Oops, nope, it's going to take a picture of the wrong thing. Hold on. That'll be better. So we were given, hang on, before I start talking, let me see if I can find the picture that I'm looking for. There we go. So we're given this function. And what we want to know, so the graph of little f is given below, and so we're looking at the derivative. So in this problem, let me write this down. We're given that little f looks like this. So it looks like we got some kind of shifted sine or cosine. Where this happens at x1, this peak happens at x2, and here we have x3. And here is the x-axis. And the y-axis happens at this peak before x1. So here's our graph of f of x, and we want to find the graph of capital F at x, where capital F prime of x is equal to little f of x. That is, what is this the derivative of? Or what does the graph of the antiderivative look like? All right, so the nice thing about this particular multiple choice problem is that we can see that f of x is never negative, so capital F of x is never decreasing. Maybe I'll record this. This might be